terrifying discovery, Webb Space Telescope could be able to detect other civilizations through their air pollution. Pollution has been a menace to our planet ever since the planet has existed. With the levels of pollution higher than they've ever been in human history, it might be challenging to point out exactly how much pollution exists on the Earth right now. Then again, the telescope we built isn't out here to tell us the amount of pollution on the Earth now. The technological marvel known as the James Webb Space Telescope, the JWST, can now add another unbelievable function to its already growing list of them. But before we continue, what we mean by this, we shall first go into the in-depth details of this telescope. This telescope comes for $10 billion, and it is NASA's largest science telescope. This telescope results from the collaboration between NASA, the Europe Space Agency, and the Canadian Space Agency. NASA involved around 300 universities, organizations, and companies across 29 states in the US and 14 countries to produce this technological masterpiece. It will probe the entire cosmos, helping to reveal what our glorious space holds. It will have such huge advantages over the Hubble telescope that the Hubble will look like a newbie when the JWST is finally functional. Speaking of the make of this telescope, the primary mirror measures 21.3 feet, whereas the sunshield measures 69.5 feet by 46.5 feet. The overall mass of this telescope is 6,500 kilograms. As for the movement of this telescope, it will orbit the Sun in a different Lagrange point, which will help this telescope stay in the same line with the Earth. It's also predicted that this telescope will take a month to travel 1,000,000 miles to its permanent resting spot. This spot will be made stable by the earlier mentioned Lagrange point. Structure. This honeycomb-shaped structure is 3 stories high and is the size of a tennis court. This telescope structure comprises 15 small hexagonal mirrors made up of beryllium coated with gold that has been optimized for reflecting infrared light from the end of the universe. Apart from this, the primary mirror backplane assembly and the deployable tower structure lift the telescope off the aircraft. The 3 arms present at the top come together into a ring where the secondary mirror will reside. The first of many things this telescope will be deploying sunshield, which will protect its surface from the sun's rays. This telescope will come with safety precautions. Other things that will be focused on once this telescope powers up are its orientation and alignment, and its instruments that will come into play. However, for this telescope to be fully functional, we will have to wait for another 6 months. The clearer images with light will take some time to come to us. Although this telescope is slated to replace the Hubble telescope in the first few years, the 2 of these shall be working together. The James Webb Space Telescope will look at our universe in infrared. It'll cause light from distant objects to shift to longer wavelengths at the red-colored end of the spectrum. This will bring in bigger and better details to the images that will be seen, and it will manage to give details about the most primitive stars and galaxies that the universe has inside of it. Another critical point to note is that the James Webb Telescope will orbit the Sun. It is oriented so that it will remain in a gravitational space instead of drifting to any of the sideways. Plus, since this telescope will orbit the Sun, this is why it has been inserted with a sunshield. Functioning areas. These are the areas in which the telescope shall be functioning. The telescope will have an insight into the events that took place after the Big Bang. The universe came to life as protons, neutrons, and electrons came together. No light could be seen as the universe cooled down and these subatomic particles combined. The telescope will look into how our universe was born and what it's become after billions of years. The organization of matter to see how these galaxies came together in different states and big and small sizes will be looked into. This gives us hints about how the universe has evolved after billions of years. Different shaped structures will be seen as they evolve from different structures. The formation of galaxies and how they came together will also be looked into indefinitely. This telescope will also focus on how stars came into being. Being clouds of gas, stars expand when they are given the heat, and when radiation is exerted on these stars, they manage to blow away all the gas on their outer level. With infrared technology in it, this telescope will help look at heat sources, especially those stars that tend to be born with these gases. Finally, the origin of planets, in which our Earth is also included, will be observed, and the vast number of planets discovered in the last decade or so, it'll be a treat for this telescope. The robust sensors of the James Webb Space Telescope will look into these planets with more depth and imagine their atmospheres during the time of their origin. Understanding the condition of other planets will help scientists to decide whether a planet is inhabitable or not. Detection of other civilizations. Comparing this to the Hubble will not be a fair comparison, but one thing is that the JWST will help in detecting signs of life on other planets. That's right, this telescope tends to detect signs of extraterrestrial life. This is because from our solar system, the recent discovery of phosphine in Venus's atmosphere managed to spark speculation that chemicals might be created using a microbial life form. Remote sensing experts have proposed applying the same concept that plant life that uses photosynthesis as energy could be detected in infrared wavelengths. Like how chlorophyll absorbs visible light but only shows up in infrared. This would give the planets a distinct red edge. Even as small as a single pixel photo of a distant planet might help us locate extraterrestrial life. Recently, a paper has been printed that examined the possibility of using this excellent telescope for searching industrial pollutants in the atmospheres of extraterrestrial life. This paper focused majorly on chlorofluorocarbons, CFCs, produced on Earth as refrigerants and cleaning agents, and these compounds also end up destroying our ozone layer. The theory that has been slipped in here is that if these compounds are found somewhere else in the galaxy, then there's a certainty that alien life might be present there. So out of everything that might help us detect outer worlds, how ironic. This, however, doesn't mean that the JWST won't have its limitations. If the star of a planet is too bright, then it will drown out the signal. This is why the telescope will have the most success by looking at M-class stars, which are dim, long-lived red dwarfs due to their earlier mentioned red edge. As examples of nearby stars is the TRAPPIST-1, a red dwarf located 40 light-years away from us. The JWST would be able to see and detect the CFCs on TRAPPIST-1's planet. This is because the dim star won't block out the CFCs in the environment like a bright star would. Our Sun is an example of a bright star for the matter. Now, if we flip the narrative that a telescope that those aliens might have built for us wouldn't be able to detect such compounds from the Earth because our Sun would easily block out anything their telescopes decide to detect. Would the aliens have a telescope for themselves? Have you ever thought about it? Whatever we find out there related to aliens, the mere fact that we're able to detect something at such a level is mind-blowing within itself. The paper which we mentioned earlier had the following conclusion in it. With the launch of JWST, humanity may be very close to an important milestone in SETI, the search for extraterrestrial intelligence. One where we are capable of detecting from nearby stars, not just powerful, deliberate, transient, and highly directional transmissions like our own, such as the Arecibo message, but consistent passive technosignatures of the same strength as ours. Now, how close alien life is or isn't is a question for another day. We already have the technology to detect them, so now it's just a game of hiding and seeking with those aliens. Will we end up winning it? Only time and the James Webb Space Telescope will tell. Thank you for watching this video. If you liked it, then press the thumbs up icon. Make sure to subscribe to the channel so you don't miss any upcoming videos. You can click on the bell icon to be notified of the newest content that we put out for you.